In the figure shown, AD is equal to 121 over 3 and AB is 11 root 130 over 3. What is the length of DC? To find DC, we're going to need similar triangles. Notice that triangles ADB and ABC share angle A and both have right angles, so that makes them similar. And similarly, triangles BDC and ABC share angle C and both have right angles, so that makes them similar as well. Now, here's the key insight. Stay with me on this. Since triangles ADB and BDC both have the same angle measures as triangle ABC, triangles ADB and BDC must also be similar to each other. Armed with that knowledge, let's start solving for sides. AD and AB are given. Using the Pythagorean theorem in a calculator, we can get BD, that's 11. So now we're clear to set up our ratios. Again, triangles ADB and BDC are similar, which means that the ratio of the short leg to the long leg of each triangle must be the same. We can flip and multiply this denominator on the right to get 33 over 121, which reduces to 3 over 11, so DC is 3. In the xy plane above, lines K and L are perpendicular. What is the x-coordinate of point P? I've already shown in the lecture and the previous problem that this configuration produces three similar triangles. So let's get straight to solving for side lengths. The long leg of this triangle on the left is 4, the short leg is 3, and let's call this distance A. We then have that A over 3 is equal to 3/4, so A is 2.25, and that makes the x-coordinate of P 6.25. Jim has a triangular shelf system that attaches to his shower head. The total height of the system is 18 inches, and there are 3 parallel shelves as shown above. What is the maximum height in inches of a shampoo bottle that can stand upright on the middle shelf? A consistent source of panic that I see from students arises from geometric questions that require them to draw additional lines. And this is indeed one of those questions. We're given that the height of the large triangle is 18, so let's drop an altitude down the center. That makes these angles 90 degrees, and because the shelves are parallel, we have corresponding angles on the left. Hence, all 3 of these right triangles are similar. To get the height of the bottle, we can subtract the height of the middle right triangle from the height of the small right triangle, but we need to find both of these heights first. Let's call the height of this middle right triangle h. We then have that h over 5x is equal to 18 over 6x. That makes h 15 inches. We can call the height of the small right triangle little h, and so we have little h over 2x is equal to 18 over 6x. That gives us a little h of 6 inches. The height of the bottle is the difference of 15 and 6, which is 9. In the figure above, BD is parallel to AE. What is the length of CE? Because BD is parallel to AE, angle DBC must be 90 degrees, and the two triangles share angle C, which makes them similar. Triangle BCD is a scaled up 3, 4, 5, so the hypotenuse is 10. Then setting up our ratio, we get that CE is 30. In triangles LMN and RST, angles L and R each have a measure of 60 degrees. LN is 10 and RT is 30. Which additional piece of information is sufficient to prove that triangle LMN is similar to triangle RST? As with any geometry problem that doesn't come with a picture, we definitely want to draw a good picture. Answer choice A kind of obviously doesn't work because the proportions of the sides are way off. But A is also wrong for a subtler reason. Notice that if we drop an altitude down from T, we have a 30, 60, 90 triangle. So the height of that altitude is 15 square root 3, which is about 26. That means a side length of 7 for TS is not even close to reaching from T to RS. So this is an impossible triangle. Answer choice B is the most trappy wrong answer because the side lengths actually would be in the correct proportion for the triangles to be similar. But again, a side length of 21 is still about 5 units short of forming a triangle. Answer choice C produces triangles with different corresponding angle measures, so that's wrong. But D gives us 3 sets of equal corresponding angles. In the figure above, AE is perpendicular to CD, and segment AD intersects segment CE at B. What is the length of segment CE? The vertical angles at B are equal. We also have alternate interior angles at C and E, and then also at A and D. So we've established that these triangles are similar. Now the key step is recognizing that side CB, which I'll call X, corresponds to side BE because these two sides are between corresponding angles. We then have short leg over short leg equals long leg over long leg, which gives us x is equal to 4, so the length of CE is 12. In right triangle ABC, angle C is the right angle and BC is 162. Point D on side AB is connected by a line segment with point E on side AC, such that line segment DE is parallel to side BC and CE is equal to 2AE. What is the length of line segment DE? Again, if you can draw a picture, then you should. So let's start with that. We have that CE is 2AE. I'll label those X and 2X. The two right triangles share angle A, so we know they're similar. All that's left now is to set up the appropriate ratios to solve for DE, but this is where a lot of you will fall prey to those sneaky test makers. We should have DE over 162 is equal to x over 3x, not 2x. From there, the algebra is straightforward, and we get that DE is 54. If you've learned anything here today, go ahead and subscribe, and don't miss my next digital SAT video on unit conversions.